So in our last video, we showed how a user who had a project on Facebook they were trying to create for Arduino was getting tripped up trying to use SoftwareSerial and Servo at the same time. And we showed through code evaluation and an experiment why you can't reliably send and receive serial data at the same time that Servo is running. One or the other of those is going to conflict with each other. And at the end of the last video, we teased the idea that a Serial Wombat 4B chip is a good way to solve this problem. And so let's talk real quick. What is a Serial Wombat chip? A Serial Wombat chip is an I2C or UART connected device that makes all of the fun peripherals of a microchip PIC available over I2C through an Arduino library. There's also MicroPython libraries and C# libraries if you want to hook up from a PC or Raspberry Pi or whatever. So as we said before, the problem that we had was we wanted a serial port and support for Servo, and that wasn't working. So I took the sketch that we looked at in the last video, I commented out SoftwareSerial and added Serial Wombat.h and added a Serial Wombat chip, got rid of the Servo, got rid of Servo.h, and allocated a Serial Wombat Servo instead. That's a servo that's being served off of the Serial Wombat chip attached to the Arduino's I2C bus. We're going to create a Serial Wombat UART. In the case of the Serial Wombat 4B, you can have one of those per chip. And essentially what it's doing is allowing you access to the hardware UART through the I2C bus. And it also provides some queuing so that if you don't access the chip right away, data doesn't get lost. That queue is not infinitely large, so you can't leave it forever, but it works pretty well. And then, so we come down here. Unlike the last one, we're going to have to call wire begin because now we're using the I2C lines. We're going to call Serial Wombat begin, tell it we're using wire to connect, and the Serial Wombat chip's I2C address is 0x6C. And then we're going to tell it where previously we would have started a SoftwareSerial that ran on the Arduino itself. Now we're going to say, hey, take pins 0 and 1 on the Serial Wombat chip and create a UART out of those using the onboard UART peripheral on the chip. Then at that point, pretty much all of the rest of the code remains the same. As I said, we got rid of my SoftwareSerial. My Servo has been renamed, and the Serial Wombat Servo class has all of the same interfaces as the standard Arduino class. And so it was unnecessary to change any of the code below this point. Similarly, the Serial Wombat UART class inherits from Stream, as does SoftwareSerial. So the DF robot people did a nice job with their DF player library, letting you hand any Stream class in as the way to get data in and out of that. So I was able to just hand it a Serial Wombat UART class instead of a SoftwareSerial, and it still works. And other than that, every single line from there on is totally the same. So we were able to run that, and it with minimal amount of code changes. The big difference that you'll see is now when we execute this thing, all of the stuttering that we saw that was a result of the SoftwareSerial conflict with the timing of the servo is gone. So let's go ahead and fire that guy up now, and we'll watch it go. So the circuit is all of the same components that we looked at in the last video. We've got our servo over here. We've got our DF robot, DF player mini MP3 player. The big difference is the way that we've got it wired. Now we're using the I2C clock and data lines. Those are going out to this Serial Wombat chip. And again, this is kind of sloppy wiring. You can't see it real well, but there's data and clock serial I2C lines here. And then we're using 3 of the I/O for serial receive, serial transmit, and going out to the servo. The servo is being powered by this USB battery. So we'll fire up the battery, plug in the Arduino Uno, which at this point is not doing any of the actual signal generation, but is still in charge of the high-level commands that are being sent out that then are being turned into signals by the Serial Wombat chip. So we plug that in. We heard it click. It's getting ready to initialize. We're getting nice audio coming out of the speaker, so we know the UART coming off of the Serial Wombat chip is working equivalently as before. And we can see the servo at this point is holding positions nicely. It's at its standard position, and we'll see it go through a sweep. We're not seeing any of the jumping that we saw when we were using the servo library that was on the Arduino. This guy will move. Very, very smooth. Coming back very, very smooth. And again, those servo position commands are coming out over the I2C to the Serial Wombat chip using all of the same interfaces that are typical. So that's a pretty good proof of concept. We could put it on the logic analyzer and show that the pulses are uniform. I don't think we're going to do that today. Not going to take up that time in the video. But I hope you can see this is a proof of concept to show that this very much solves the resource problem that we uncovered in the previous video. So the Serial Wombat chip itself is open source. The firmware, let me unplug that. The firmware is available on GitHub. The Arduino libraries, of course, are open source and are available. And as are the MicroPython and C#. You're welcome to get a microchip pick kit and program them up yourself if you like. Alternatively, you can get pre-programmed kits on Amazon that come with in the case of the 18AB, a PCB, or in the case of the Serial Wombat 4B, just 4 little chips and the required capacitors. There's also the add-on mounting chip that for the 8-pin dip if you want. That includes the necessary capacitor and a place to solder on I2C resistors if you want. So anyway, it's a big project I've been working on since probably about 2018, and some people are starting to like it, and we're starting to get a little bit of community interest. So hopefully it'll be something that's useful for you. If you have an application for the chip, definitely leave me some feedback if there's something you like or don't. You know, I take into account a lot of user requests and try to incorporate those requests into the firmware and into the libraries. So happy to do that. And that's all for now. Have fun, keep making stuff. In our next video, we will actually finish the wigwag controller and build a little option of that kind of goes through the architecture and how I might control that and try to give it some physics and light control and things. The Serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Incorporated. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.